And good afternoon, everyone. Welcome here to the launch pad. We are awaiting a press conference with NASA and Boeing executives to give another update about the Starliner crew flight test. It was expected to begin about 2 minutes ago, but they have not yet actually begun that press conference. So we are standing by, waiting for that to begin. The moment that it does, we will, of course, patch that in for you guys to be able to have the live audio there. So please stand by.
Stitch. Go ahead, Steve.
Yeah, thanks, Steve, and thanks to all of you for joining in today. I appreciate your interest in the Commercial Crew Program and our crewed flight test. I'm happy to be here today. Special thoughts and prayers to those in the Houston area following Hurricane Beryl that made its announced arrival a little earlier this week. We know there's a lot of people that have damage to their homes. And we're without power in the Houston area. I'm one of those, so keep them in your prayers, and it'll be a long road ahead over the next few weeks. We had hoped to do a camera interview today, do the briefing via camera, but unfortunately, today is the first day that the Johnson Space Center is now back open, fully open for business. There's repairs going on across the center, and we just could not have enough people in place to support that. So hopefully the next time we'll get the right group together and we can do a camera interview or a camera media telecon. I'm supporting from my office. Mark Nappy's with us from Florida. We look forward to telling you a little bit about what's going on today. I know many of you had the opportunity earlier to listen to Butch and Sonny and ask them a few questions to talk about how the flight test has been going so far, and so I'm glad that you were able to talk to them and get firsthand their view on the crewed flight test and how great the mission's going. We're taking our time on the ground to go through all the data that we have before we decide on the return opportunity. We're taking time to build confidence in the spacecraft, to understand the thruster performance, those aft thrusters that failed off during docking, and also totally understand the helium margins before we undock. What we're doing is not unusual for a new spacecraft. I think Ken Bowersox put it very well last time we talked, that now that we have ISS and the ability to power a spacecraft from ISS, we have a nice opportunity to almost use the International Space Station as a temporary hangar to take our time and understand the spacecraft before we undock and return. We don't have a lot of big news to talk about today, but we wanted to spend a little time to update you on the testing and the work that's going on. The team's doing a great job working through the testing at White Sands, which I'll talk about, and Mark will as well. and then on the helium leaks as well. And a little bit of a hiccup, I would say, with the Hurricane Beryl coming through. Some people are actually impacted and not able to work as much as we would hope, but we're still continuing to make a lot of progress. Since we last talked at the White Sands Test Facility in Las Cruces, New Mexico, we have started the ground hot fire testing that we talked about. We put the thruster in the chamber on July 3rd and actually did an acceptance set of tests with that thruster. It's just to verify that that thruster is healthy before we put it through the performance that we needed to understand the flight performance of that particular thruster. It passed all its checkouts, and then so we've started through the profile we talked about last time. And so what we really want to do is we picked one of the thrusters which had a little bit of the low end of the thrust. It was around 80% or so thrust. We are going to replicate what that thruster saw to the best of our ability for the uphill part of the mission. So on flight day 1, there was some crew maneuvering that was happening with that thruster, and then on the rendezvous day, there was some pulses that happened as part of the normal rendezvous sequence. We're going to take that thruster and try to replicate that sequence as best we can. So we've tried to replicate a lot of the thermal aspects. In other words, what that thruster saw going into the rendezvous day. We point the solar rays at the sun before that. We try to add some heaters to the thruster to simulate that. And so right now that thruster has been through all the uphill phases of the flight, and we're now in the process of looking at all that data before we move to the downhill portion. The temperatures we've been able to achieve are not quite what we would have hoped for. Based on the flight data, we know in what's called the injector, which is where the propellants mix, what the temperatures were. So we're probably a little on the low side. The teams are off looking at that data and trying to determine the next steps. And then the idea is to take that thruster and put it through the downhill phase of the flight. And the most stressing part for the aft thrusters, they are used not to execute the deorbit burn, but also they're used for attitude hold during the deorbit burn. And so we'll put that thruster through that. And we hope to get through all that testing this week or over the weekend. So that's going on at White Sands. And then really the purpose of that testing is to be able to look at the thruster. The thruster is instrumented. It has many temperature sensors on it. And to examine the thruster and just to make sure that there's no negative effects on the thruster from any of those pulses that it would have seen in flight. And it was chosen to be, this particular thruster that we were emulating was chosen because it perhaps saw the most stressing set of pulses for the flight. On the helium leak, we hope to bring that into the Starliner mission management team for final resolution later this week. The team has been working really hard on trying to understand that story, to double and triple check the margins related to the rest of the flight. And then a lot of testing has happened at the Marshall Space Flight Center, where we've taken a simulated, we talked about the flange leak on the P2D2 flange prior to the flight. We've taken a mock-up of that flange and put it through various stressing cases with lots of heat simulating the pulses from thrusters. We've cycled that particular flange many different times with pressure cycles that we would have seen in flight and even more. We've put seals in that testing that have had intentionally cut seals with imperfections. And we've really shown that the seal itself has been pretty robust in that testing. We've actually applied different amounts of grease and done all kinds of testing. And then also at the White Sands Test Facility, we've also been looking at Service Module 2, which was used for the first set of attempts for Orbit Flight Test 2, and tried to understand the potential leaks on that vehicle. And that vehicle has been exposed to hyperguls for an extremely long time. It's almost been wetted in some form or fashion for 3 years, and try to characterize performance of that vehicle to give us a little bit more confidence on in-flight potential swelling from exposure to NTO. So we've talked about before, Starliner is go to return in emergency. If the crew needed to return at any point in time, it's go for return for any kind of emergency on board station. We're going to work methodically through our process including a return flight readiness review with the agency before we give the go to proceed toward undocking and landing. This is a very standard process, which we use for all of our Dragon missions. We use that for Demo 2, and we use it for every single Dragon mission that we're going to go fly, including the one coming up. We will have, as part of our readiness for Crew 9 launch, we'll do a Crew 8 readiness return review as well as part of that. So happy to answer questions, and I'll turn it over to Mark Nappy next.
Good afternoon, everybody, and thanks for joining us. First, I'd like to thank NASA for the opportunity for the media event today with the crew. All work stopped today on our program, and the teams really enjoyed watching Butch and Sonny do the media event. It was very uplifting to hear what they had to say. I'll keep it short with my opening remarks and just talk a little bit about what we've been doing and some of the lessons learned so far. There were a number of specific actions that were identified from both the helium and the thrusters anomalies. It's just a little bit over 30 of them, of which more than half of them are closed at the moment. So what we're doing is some of these are items like the test that Steve mentioned. That is the biggest item to work off, but there's a lot of very minor types of closures where we're furnishing some artifacts from previous testing or model analysis or doing some analysis to anchor some of our engineering conclusions. So those are being worked off. All these items are scheduled to be completed by the end of next week. The engineering teams are meeting every day on these items. The chief engineers on both the Boeing and the NASA side are engaged to make sure that everything's being addressed efficiently. And then we have mission management team meetings that are hearing the pertinent closure of these items several times a week. We've got program plans and schedules that are being published daily on the progress so we can plan ahead and keep providing help where it's appropriate. An example of the hurricane barrel that came through, obviously unplanned, did impact the resources that we have at JSC and in Houston at the Boeing facility. So, with those resources not being available, we had to reprioritize some of that work and reorder it so that we could still try to stay on plan. In parallel, we've been also working on some additional items with respect to Starliner 1 hardware. We're doing testing and inspections of the service module for Starliner 1 on the doghouses and the helium system to see if we can't duplicate what we've seen in flight and see if it does exist on that service module. We're disassembling and inspecting all available service module doghouses that we have. That includes some that we have for future flights, and like Steve talked about, our service module 2 from OFT hardware. We've also been taking that apart and seeing if there's anything that we can learn from it. We knew that there'd be some learning from this flight test. We've learned a great deal from how the hardware works, how our processes work, and how we can improve the things that we've been doing, even to the extent of how we've been sharing information with the public through you. You've done a nice job at giving us feedback so that we can make adjustments for the future. All this learning has been pretty valuable, and we've made some adjustments, and we'll continue to make more. After we land, we'll do we call them post-test or hot wash, and we'll look at all the lessons learned and apply the corrections as necessary. Let's shift gears a little bit, talk a little bit about how the team's doing. We talking to some of our young engineers. One of our engineers, Amy Decker, out of the chief engineer's office, and we talked to her about how she thought things were going, and she was really excited. And to take her quote, she said, "The extra data we're getting, being up here for a while, is awesome," and all in caps. She just is. Engineers are just, when more time that you have to get more data, the more excited they get. So it was really nice to see that they're really engaged in these issues. They're really engaged in learning as much as they can for the spacecraft and moving forward. And bottom line is, as engineers, we test, we learn, we fix, and that's exactly what we're going through. We have a long history of doing safety and quality stand downs, and we had one here yesterday at the Florida site. And during that, we had Scott Tingle and Mike Fink come in and talk to our team, and they expressed full confidence in our spacecraft and our team. And in fact, Mike emphasized the importance of how all the systems work together, and that's the kind of learning that we're getting out of this test flight. It also was really good to hear from Butch and Sunny and how great the spacecraft operated. If you listened to their media event earlier, they talked about their confidence in our vehicle and our team and our training, and the willingness to get in that vehicle and come home at any time. So with that, I'll turn it back over to Steve.
Thank you, Mark, and thank you, Steve. We're going to go to media questions. I did want to note one thing that we've been asked quite a bit about, and that is that we do anticipate another crew news conference with Butch and Sunny before they depart the space station. So more details to come on that, but that is on our radar. So just wanted to note that for folks. Reminder to please hit *1 to get into the question queue. And our first question is going to go to Marcia Dunn from the Associated Press. Go ahead, Marcia.
Thank you. Hello. Based on what you both know today, when is the earliest the Starliner might come back? By the end of July, not until August? And what's the longest it could remain at the space station at this point? Thanks.
Yeah, Marcia, I'll take that. This is Steve. Yeah, the big driver obviously is the handover that we have coming up between Crew 8 and Crew 9, which is in mid-August. So, we'd have to back up. We haven't yet done that yet, but, obviously a few days before that launch opportunity, we would need to get Butch and Sunny home on Starliner. So that's kind of the back end. I think we're really working to try to follow the data and see when's the earliest that we could target for undock and landing. I think some of the data suggests optimistically maybe it's by the end of July, but we'll just follow the data each step at a time and then at the right time figure out when the right undock opportunity is.
Thank you. And next we're going to Bill Harwood from CBS News. Go ahead, Bill.
I can figure out how to unmute this phone. Can y'all guys hear me?
We have you.
Oh, thanks. Well, just to follow up on Marcia's question, Steve, is there the only number we heard before launch was the time on the batteries. I'm just wondering, as this is day 35 today that you've been off the ground. I'm just wondering if whenever you choose to come home, whether it's end of August or whatever, end of July, whatever, are any waivers required for that? Were there anything written down before launch that said this is when you need to come home, and now you're going to change that, and you would have to do some kind of waiver? Thanks.
Yeah, thanks for your question, Bill. The biggest one really is the batteries. We had set the 45-day limit prior to launch, and that's the one that needs to be processed. As I talked last time, we know that the batteries are healthy on Starliner. They're not really showing any signs of any performance anomalies at all. So, the way the battery risk works is any day is the same amount of risk. So I think that's the main one. There's a few others we'll have to go look at relative to lifetime on a couple of handheld devices and batteries and so forth. But that's probably the biggest item that we've got to go work through, and the team's doing that right now to give us the margin we need.
Thank you. Next, we're going to go to Michael Sheets at CNBC.
Hi, everybody. I wanted to hear a little bit more about the white sands testing. As far as, acceptance testing the new thrusters, how is that different than the prior acceptance tests that were done on the thrusters in orbit? And why was the acceptance testing of the currently flying thrusters inadequate if you've had to change anything? And does this mean that there's going to be a redesign for the Starliner 1 thrusters, or what have you learned so far since the first test of July 3rd? Thanks.
Yeah, Steve, maybe I should start. First, this is not acceptance testing that we're doing with this thruster. This testing is trying to replicate what the worst case thruster saw in flight. So our qual testing was sufficient for the thrusters. What Steve mentioned earlier is that so far we've not been able to replicate the temperatures that we saw in flight. So the team is off talking about that, matter of fact, right now, so that they can determine whether or not there's a form of testing that we want to go change, or something in the test that we want to go change so that we can replicate that situation. And then once we do, we will go and run the downhill profile for the thrusters to see how that compares and how the thrusters operate. So now, does that mean that there's a change in the thruster itself? I would say no, and Steve can weigh in on this as well. What we're trying to learn here is, are there profiles, the way that we fly the flight, do we want to change that a little bit? Are there limits that we want to set differently in our software on how to deselect the thrusters? Those are the types of things that we want to learn. Over to you, Steve.
Yeah, thanks, Mark. I think Mark said it really well. You know, every thruster on the vehicle is acceptance tested, and so that is when the thruster comes from the manufacturer, it goes to White Sands and is checked, and so that's just a health status. It's fired for a number of specific pulses and durations, and that just checks that, makes sure that the thruster's working the way it is, it's producing the right thrust, using the amount of propellant it's supposed to use, and so forth. I think Mark said it really well. What we found in this flight is we have fired the thrusters more than expected, and then I would say more frequently. When I say frequently, I'm talking about how close you fire an individual thruster pulse to the next pulse of that thruster. And so what we're trying to do at White Sands is really replicate exactly what those pulses were that the thruster saw, and then understand the heating effects from those pulses, and just to make sure that there's no unintended consequences of those pulses. And as Mark said, I think there's ways now to what we've learned from this flight to change the number of pulses required for the rendezvous and docking phase, and not put such demand on the thrusters. I think that's the work in front of us for Starliner 1.
Thank you. Next, we're going to Joey Roulette from Reuters. Go ahead, Joey.
Hey, thanks. For Steve, I think earlier on the call you said during the hot fire testing on the ground, you've seen temperatures that are not quite what we hoped for. What do you mean by that? What is not what you hoped for? What were you hoping for? If you could just spend some time going into detail on that, that'd be great. And then Mark Nappy, when you guys are taking apart the service modules for the future Starliner spacecraft, what are you looking for? And based on what you know now, what changes do you expect to make to those service modules, and will that affect, readiness for the future, et cetera? Thank you.
Yeah, I'll start with the temperature part of the question, and then we'll let Mark answer that. What all the great work going on disassembly of the doghouses. We know from measurements on the thrusters, the 5 thrusters that the software deselected on docking day. We know what the thruster itself. There's what's called an injector temperature measurement, and that's what we are trying to replicate. And so that temperature was achieved by firing the thruster, and then also the fact that the thruster is located within the doghouses that we talk about, the port, the starboard, the top, and the bottom. And inside the doghouse, you can almost think of it as like it has insulation to keep the propellant lines warm during the dock phase, but it also kind of will retain heat. And so we did our best that we possibly could at White Sands by trying to mimic the effects of the doghouse in adjacent thruster firings by using heaters on the thruster. When we do that, for certain phases, we match pretty well. Other phases were a little bit low, on the order of 20 or 30 degrees low. And so we're trying to understand, before we get into the downhill phase, is there anything more we need to do to try to get the temperatures up a little higher during that final phase that we're simulating and replicating at White Sands for the dock phase. When we know the thrusters failed, we're deselected by the software. And I'll let Mark answer the second question.
Okay, so this is in probably a couple of different answers because what we're doing with the service modules is different for each type of vehicle. So for the service module that is going to fly on Starliner 1, that vehicle is already put together and the dog houses are installed on the service module. So what we're doing on that vehicle is running a series of leak checks to see if we can't determine whether or not it has the same susceptibility to a leak like we've seen on the current service module. So that testing's in work, and based on that testing and based on our determination of root cause in the future, we may have to take those dog houses off and take each thruster off and potentially replace some seals that we suspect might be undersized. So that's what is going ahead with service module. We call it service module 6 because that's the one that's being built for Starliner 1. For Starliner 2 and above, those dog houses were just delivered to us from our supplier, and they were planned to be disassembled so that we can take each thruster, send it out to White Sands, and have their normal ATP performed on them. So while we've been taking them apart, we've been taking a little bit of extra time to look at the interface of that flange area where we believe this helium leak is coming from, looking at those seals, making sure there's nothing in that interface that could cause the leak, and just collecting all that information so that we can plug that into potential testing that is currently being done at Marshall or that may be done in the future to determine root cause. And then the last one is Service Module 2, which I talked about earlier, that was used on OFT but did not fly. That vehicle was exposed to propellant, so we've got it out at White Sands, and we're taking it apart real slowly and doing the same thing that we're doing on the future dog houses and doing the inspections of those flange areas to see if there's any anomalous conditions in there that could have potentially caused this type of leak. So all this information is going to go in a big bucket, and all the engineers are going to review it and try to see if it doesn't point to root cause or point to some additional testing that we can do in the future to eliminate this problem once and for all.
Thank you, Mark. Our next question from Micah Maidenberg at Wall Street Journal. Go ahead, Micah.
Hey, good afternoon. So Steve and Mark, we've been going over the work on the thrusters and the helium leaks and how the team has been reacting to those issues. I guess my question is, at some point, do you have to potentially stop reacting to those issues and shift to potentially using a different vehicle, for the return? I mean, is there some sort of preset trigger or red line that you would potentially cross that would sort of mandate or prompt such, that kind of a shift? Thanks.
I can start and then see what Mark has to add. I think the testing at White Sands is hugely important as part of that. Taking the data that we learned from White Sands and looking at the thruster and inspecting it physically, just to make sure that with all these pulses and all the heat we're putting into it, that it doesn't cause any damage to the thruster at all. The data from the flight suggests that the thrusters, except for the one thruster that did not recover, are operating just fine. I think that physical inspection is probably the most important thing that's going to happen over the next week or so. And then, after that, we've talked about the beautiful thing about Commercial Crew Program is that we have two vehicles, two different systems that we could use to return crew, and so we have a little bit more time to go through the data and then make a decision as to whether we need to do anything different. But the prime option today is to return Butch and Sunny on Starliner. Right now, we don't see any reason that that wouldn't be the case. Again, this White Sands testing is probably one of the key things to look at the thrusters and make sure that we all the engineering data suggests that the thruster is performing well and has not sustained any damage in flight. In fact, the thrusters have been fired. Even the one thruster that was producing very low thrust, we're not going to use anymore. It was fired 270 times on docking day. One of the thrusters was fired under 450 times on docking day. And so I'll turn it over to Mark and see if he has anything to add.
I think the way you kind of concluded there was where I'm at. Plans are to bring the crew home on Starliner. We see no reason why that should be changed. We've got good hardware. We're trying to add to the engineering database of, so that we can bring good flight rationale together to our senior mission management team, and provide more information so that we can, again, fix these problems once and for all.
Thank you both. Next is going to be Chris Davenport at the Washington Post. Go ahead, Chris.
Thanks, Steve. Regarding the flight profile, the RCS thrusters were obviously very important for docking. We just heard Butch talk about how precise it had to be, but I just sort of wonder, how dependent are you on the RCSs for the return trip? I wonder if there's any way to characterize how much they'd be firing on the return as opposed to on the uphill portion of it, and what that difference is, especially if the overheating is an issue. Thanks.
The biggest, great question. The biggest demand for those aft thrusters for the remainder of the flight is at the deorbit burn time frame, and it's really not. Those thrusters aren't used to provide the thrust for the deorbit burn. Those are the OMACs. We'll fire 4 OMAC thrusters out of the 12 that we have. We know all 12 OMACs are working just fine. We know that the propellant feed system for all the OMACs are working just fine. But the biggest demand is several hundred pulses during that deorbit burn to maintain the OMACs fire to provide the delta V for the deorbit maneuver to bring the vehicle back into the atmosphere, and then the RCS thrusters fire associated with those OMAC firings to just hold the orientation of the spacecraft as that deorbit burn is executed. And so that's the biggest demand coming up for those thrusters.
Thank you. And next, Gina Sunseri at ABC News. Go ahead, Gina.
Yes. Moving on to when they undock, what tests do you have for the crew for Starliner on its flight home?
Steve. Go ahead, Mark.
So they're the nominal. There really are no tests that we have to run once we undock. We have a series of operational checkouts that we're currently going through to see whether or not we want to run those after we undock. But the majority of the work that has to be done after undocking is just nominal return.
And I would add to that, obviously the whole undock to landing and then recovery of Butch and Sunny are part of the test flight. So for this unique undock and deorbit landing sequence, the biggest change, obviously, from OFT2 was we have Butch and Sunny on board. So, I'm sure we'll learn a little bit about getting in the seats and the suits and all those sorts of things. But those are all nominally planned activities. There's no special test for those. And then, how the vehicle does relative to the heat load of the crew and comfort of the crew during deorbit landing. And then we'll have accelerometers on the seats to measure the acceleration during entry, the G loads, the Gs at landing, and so forth as part of the test flight. Those are all, I would say key parts of the test flight. But other than a couple of maneuvers that Mark talked about, the OCCs, which we're debating whether to do or not, the rest of the flight is really learning our first landing with crew.
Thank you. And next we're going to Lauren Grush at Bloomberg. Go ahead, Lauren.
Hi, thank you so much. So I'm wondering, if you were to bring Starliner home right now in case of that emergency you're talking about, what would the thruster profile look like without the white sands testing being done? And I know this requires speculation, but can you give us an example of what you might learn from that downhill phase of testing that would change that profile Would you turn off certain thrusters? Would you somehow limit the pulsing? Just curious how different it would be from the emergency scenario now.
Steve, I'll try to give this a shot and see if you want to add something. After undocking, if we were to have to do that today, we would just perform a nominal undocking and return. The propulsion system is highly redundant on each other. So if there was an issue with any one of the thrusters, the redundancy would take over and bring us safely home. Again, what we're trying to do with this testing is fill in some gaps because what the concern, it's not concern, but what we're trying to do is understand if the thrusters are performing nominally, then we will be able to undock and just return nominally. If the thrusters were somehow damaged, then what would we do differently? We don't believe that we have damaged thrusters, but again, we want to fill in the blanks and run this test to assure ourselves of that.
Yeah, I think Mark said it well. The only plan we would have right now is there's one thruster that was producing very low thrust that we would disable for the rest of the flight, and that's going to be the plan for the nominal into mission whenever we have the nominal deorbit, and that's the plan for undock right now. That would be the B1A3 thruster. We would not have that thruster available, and with the OMAX system that we have in place for the deorbit burn, that should happen nominally. We have 12 good OMAX, and then based on the data, engineering data we've collected during the flight, we expect that the thrusters would perform just fine with the number of pulses that they have on them. We have run engineering analysis and simulations with many of those thrusters failed, just to understand what that would do to the deorbit burn. And the deorbit burn sequence is very robust to any kind of thruster failure. So even if some of those thrusters were to fail off like they did on docking, the deorbit burn would be successful and the entry would be nominal.
I'd add one more thing that probably should have mentioned in my answer is that, we do have a lot of confidence in the thrusters as they are today. If you remember, shortly after we docked, we did a docked hot fire test where we fired 4 of those thrusters, and they all came back to either a nominal or very near nominal performance. So that's what gives us a lot of confidence that we have a good set of thrusters right now. With the extra time, though, let's go run this test and let's go try to replicate what we saw in flight and assure ourselves of that.
Thank you. Next, Tom Costello at NBC News. Go ahead, Tom.
Hi, guys. Thank you for the update. Just essentially following up on everything you've just said and understanding your confidence right now in the thrusters, your confidence overall in the ship. Is there any concern that if you had a replication of the thruster issue again on reentry, that the ship would somehow not make its target landing spot in New Mexico?
Yeah, that's a great question. From the simulation data that I've seen, we could lose many of those thrusters, and I don't have it in front of me, so I would hate to say all, but we could lose many of those same thrusters on the deorbit burn phase, and the vehicle would be just fine. We would be able to execute the deorbit burn just fine. In fact, some of the modeling of that deorbit burn had some more extreme failures where we lost pieces of avionics that took down multiple thrusters, and we still had good control margin. The OMAX themselves are set up to actually help. They normally just fire, 4 of them fire for about 60 seconds in a steady state fashion, but they are also set up to actually turn on and off, if you will, to actually help control the vehicle. It's a great safety feature that Boeing has and a level of redundancy that Boeing has on Starliner. So really what we're doing is just taking the time to make sure that we have looked under every rock and every stone and just to make sure that there's nothing else that would surprise us. I think that's probably the best way to describe what we're doing as we take the extra time. It's a test flight. and the first with crew, and we're just taking a little extra time to make sure that we understand everything before we commit to deorbit, and we have the time at station. So.
I'll add to that, Steve. That very question that the gentleman just asked is one of the actions, one of the 30 actions that I talked about earlier. And the team is working through that and getting ready to present that to us this week with the answer that we'd be safe to come home.
Thank you. And next we're going to Kenneth Chang at the New York Times. Go ahead, Ken.
Hi, thank you. This is for Steve Stitch. I was wondering if you could sort of compare and contrast the current situation with Bunny and Butch and Starliner with that of Frank Rubio, who I think is fair to say really was stranded on ISS after the coolant leak on the Soyuz. And in that case, NASA clearly wasn't comfortable with him returning on the damaged Soyuz, even in an emergency. So I understand that the prime option right now is for them to come back on Starliner, but has there been any work looking at any backup option on Crew Dragon or whatnot? Thank you.
Yeah, that's a great question, and certainly that situation was a little different. We had that relative to the Soyuz, we knew that the coolant system on that service module part of the Soyuz had totally leaked out, and so there was a lot of concern about what happens when that service module cooling system is used to transfer heat from the descent module on Soyuz, and so the temperatures inside the Soyuz module would have gotten pretty warm for entry, and there was a lot of concern about not only the crew but also the avionics. And so, in that case, we decided to use Dragon as a contingency return option for Frank, and had it set up to if we needed to use it as a lifeboat, we had a configuration of Frank in the mid-deck of Dragon. I mean, certainly we've dusted off a few of those things to look at relative to Starliner, just to be prepared in the event that we would have to use some of those kind of things. But again, our prime option is to return Butch and Sonny on Starliner. We've declared Starliner safe to be an emergency return vehicle. In fact, we actually had the crew get in it a week or so ago when we had the breakup and power up Starliner in the event that they would have to depart station. So we're pretty far away from where we were with the Soyuz. We just want to understand the thrusters a little bit more before we commit to the final undock and return.
Thank you. We're going to go to Jeff Faust from Space News. Go ahead, Jeff.
Thanks. You mentioned that the temperatures you've seen in the White Sands test weren't able to replicate what you saw on the actual spacecraft. Is there anything else in the test that you've seen so far that allows you to at least narrow down the fault tree of what's going on with the thrusters that might cause them to be deselected? Thanks.
Steve, I can start. I've been getting daily briefs from our team. One of the key learnings I think that we've gotten out of this so far is the fact that we get a great deal of thermal kickback from the doghouse itself. And so not all the heat is coming, directly from the thruster or through the injector of the thruster. We're getting quite a bit of heat soak from the doghouse. So that's good information to have as we move forward and determine what the future mission profiles are going to look like, how we put the tolerances in the software so it how it deselects these. It's good information, so I think that's a key learning so far. Over to you, Steve.
Yeah, I haven't seen anything else in the data so far that indicates any other learning. I think, we tried to do our best to replicate that profile that you talked about, Mark, and then the doghouse effects. It's almost like, I think of it as almost like a thermos. The doghouse acts as a thermos and doesn't let heat out, and that's the part that's hard to replicate in the test chamber at White Sands. But other than that, I don't know if we've got into any of the inspections today, Mark, or not. But I don't think we've learned anything else.
Thank you. Next, going to Marina Corin from The Atlantic. Go ahead, Marina.
Hi, this question is for Steve. You've said multiple times now that Starliner could come home right now in an emergency situation, but is a return journey in a nominal situation directly contingent on the ground testing of thrusters that you're doing now? Have you decided that undocking before this testing is complete would be the wrong decision? Thanks.
The ground testing is important to us, and I think we'll have it wrapped up this week or the weekend. I think we really wanted to get that testing completed and actually physically inspect the thruster before we committed to the nominal undocking. We really want to also put all the data together. I think one of the things that Mark and I maybe haven't done as good a job as we could explaining how much data is involved in putting together the final pieces of the flight rationale for both the helium system and the thrusters. The Boeing team has done a great job at looking at all the thruster performance for the entire flight, and so that's a huge amount of data. Ran simulations, as I talked about, of looking at various potential thruster failures, modeling thruster failures for the deorbit burn and other parts of the undock to deorbit and landing scenario. So a huge amount of computer modeling that we want to put together and understand. We want to also step back and make sure that we're not missing some integrated effect between the helium leaks in several of the doghouses and the thrusters themselves. And so we want to take our time to go through that data and then make sure that we're not missing something there. So really, I think in addition to the thruster testing, what we're really doing is laying out each piece of the data, and Mark talked before about fault trees for each one, and just to make sure we're not missing anything before we commit to undock and landing.
There's one more piece I'd add to that, Steve. I've talked about in the past that this test is going to, depending on how much we accomplish in this test, I'll just throw a nominal thing out there. Maybe there's 10 things we wanted to learn from this test. If we learn 8 and there's 2 more we could learn by doing additional tests while docked with Starliner on ISS, we certainly want to take advantage of that. And you can't understand or you can't define what that additional testing might be until you finish the test on the ground. So from that standpoint, yes, I would like to finish the test on the ground to determine, is there something else we want to do in flight that's going to help us understand this problem so we can fix this problem once and for all.
Thank you. Next, we're going to Irene Klotz at Aviation Week. Go ahead, Irene.
Thanks, Steve. This is for either one of you. Butch this morning talked about the low thrust during docking, although obviously he was very complimentary of the system and how it ended up performing anyway. But I was wondering if you could just please clarify if that underperformance was due to the ongoing disabled E183 thruster or due to underperformance of the 4 that were recovered prior to docking, and if there's some way to quantify exactly what was the underperformance overall during docking. Thank you.
I can give that a shot first and see if Steve wants to add anything. So what Butch was talking about was that after the first time the thrusters were deselected, we brought them back online again, and he had manual control, and he could feel that the thrusters were not operating at 100%. And what he was feeling was that because of the time that the thrusters had to recover and see that their thermal profiles came back down to normal, they did not operate at 100%. The heat was still there, so they did not operate at 100%. Once they cooled off, then they went back to operating close to nominal. So that was his answer this morning, was that he could feel that thruster not working at 100% and working at, say, 50 or 80%. That was something that he could detect when manually controlling the vehicle. Again, once we got on station and the thrusters were cooled down, we did the hot fire test on station, and they returned to nominal. So our working theory is the heat is what was affecting them from first of all, being deselected, and second, operating at less than 100%. Our reentry profile is much less demanding, and if there is no damage to the thruster should perform nominally, and that's what gives us confidence in our flight rationale. Over to you, Steve.
I don't have anything to add, Mark. Thank you.
Thank you both. We're going to go to Stephen Clark at Ars Technica. Go ahead, Stephen.
Thanks, Steve. I think my question maybe for Mark Nappy, although Steve Stitch can hop in if he wants. On the helium leak, Mark, you mentioned one of the theories you may have is the seals may be undersized and could be contributing to the helium leak. And you're going to look at that on the doghouses on the service module for Starliner 1. What makes you think that is a hypothesis, and would that be because the seals that were delivered maybe didn't match your spec from the supplier, or is that a design issue? Thanks.
Yeah, good question. I probably shouldn't have said undersized. So when we were on the ground and we had the first leak in the system, we did take that doghouse off and we did bubble soak around the whole entire doghouse, all the flanges, all the interfaces that were potential leak paths. And what we found was with the bubble leak soak is a leak at the flange area where the two propellant lines go through and the helium port goes through. So it's a pretty simple design to where there's just a hole with an O-ring around it. And obviously helium was getting out from that flange area and somehow getting around that O-ring. So the initial analysis of that said that the design should have been sufficient, but there's obviously something going on in that cavity that we don't understand, whether there was some kind of foreign object debris in there, or Steve talked a little bit earlier about excess grease being applied to that flange area, which has affected that sealing surface, or maybe that design is slightly marginal and just with excessive heating or again FOD or something, the helium is getting around that O-ring. So what we would like to do is we'd like to duplicate that design on the ground under a controlled test and see if we can't make it leak, and then experiment with some larger seals or maybe a different material seal that may not be as susceptible to degradation from the propellant, and see if we can't make this anomaly recreate and then put a new seal in and stop it.
Thank you. And next we're going to go to Will Robinson Smith at Spaceflight Now. Go ahead, Will.
Yeah, thank you, Steve. Question for Steve Stitch. You mentioned the probable undock and return is likely at the end of July now at this point, if all the tests continue to go well at White Sands. If more time is needed to comb through the data, though, from the thruster tests and the work being done on the helium leak, could a scenario be entertained sort of like where Crew 2 did not have a direct handover with Crew 3 and Crew 8 could undock from their current port and Crew 9 dock where they currently are to allow more time for Starliner to remain on station? Thanks.
Yeah, that's a great question, Will. We've talked a little bit about that. If we got to the point that we had gone through all the data for Starliner and we were confident that it was good to go to do the normal undock and normal deorbit and entry, I think that is an option we could entertain as long as we had confidence in the Starliner vehicle for nominal deorbit and return. We could talk about that. We've started looking at that a little bit. We haven't done that extensively. We prefer to do the direct handover like we have, but that is an option that we could entertain if we needed to.
Okay, thanks. Next, going to Sawyer Rosenstein at NASA Spaceflight. Go ahead, Sawyer.
Thank you so much for taking questions. In terms of crew resource availability, I know there were certain crew items that were removed to make room for the urine processing facility part that had to be added. With it going near that 45-day mark, how much is set aside for them in the capsule in terms of, clothes, personal items, et cetera? And how much of the stock of where the ISS is that kind of eating into, if any?
I'm not aware of any issues relative to clothing availability or food availability. We don't really have any issues relative to that for Butch and Sunny staying a little longer than planned. Obviously, Dana's not here today, but there's a pretty big resupply mission coming up around the early August timeframe. There's a Northrop Grumman flight that's a big resupply in August, so that will really replenish the space station at that point. So I'm not aware of any issues in that regard.
Thank you. Going next to Marcia Smith at Space Policy Online. Go ahead, Marcia.
Thanks so much. And getting back to that 45-day battery lifetime issue, I'm still trying to figure out how you went from pre-launch, where someone had decided that 45 days was the battery lifetime, and now post-launch, you're saying that any day is the same amount of risk. So could you just walk me through that as to how you changed your philosophy or your understanding of the batteries and their lifetime? And you said that there's no indication that there's a problem with the batteries. What kind of signals or symptoms are you looking for that would tell you there might be a problem?
Yeah, we had set a certain risk level relative for the batteries that was equivalent to about 45 days prior to the mission. What we've been doing is we can compare voltages from every single cell and every single battery. There's 12 total batteries. I think there's 512 cells per battery. We look at the individual cells and how they're performing relative to each other. And if a cell or even a submodule in the battery had lower voltages or lower output, that could be indicative of some kind of health issue relative to that particular part of the battery. And so we get all this data on the ground. We've been watching it for the entire flight, and so we don't really see any degradation in any of the cells. And so if the cells are healthy, essentially the risk level of having some imperfection in the cell is the same for those cells as it is in any of these cells, which are commonly used in electronics all across the country. So when we looked at that, essentially if you don't see any signs that the battery is degrading or any of the cells are degrading, then your risk level for any given day is the same. Therefore, the next period of time would be the same risk as the current period of time. 45 more days would be about the same risk. So that's kind of how we got through that, by really looking at the health and performance of the batteries. And that's something we didn't know pre-flight, so that's why we couldn't just sort of extend the risk, if that makes sense.
Thank you. Next, going to Richard Trebu of the Orlando Sentinel. Go ahead, Richard.
Hi, thanks for taking the time to answer our questions. This delay in arriving home, I know that SpaceX Crew 10 was running concurrent with Starliner. I would like to know at what point you will make the call as to which of the two missions will target that February 2025 launch date, and or if you've already made that decision. Thanks.
I think Mark can add to what I'm going to say, but we've talked a lot about waiting till we get CFT, Butch and Sunny home on CFT, return the vehicle back, and then looking at the amount of work that it's going to take to get to the Starliner 1 mission, and we're double booked it with Crew 10. I think the longer we go, probably the more risk there is to that date in February. But we'll make the decision once the vehicle returns and we lay out the work, and I'll see if Mark has anything to add.
That's accurate. I'd say the two things. One is the cert process is continuing. There's plenty we can do without CFT data. But once we land, there's a post-flight assessment that we need to do that feeds into our certification data. We have to understand our in-flight anomalies and get those semi-resolved before we get certified. And then lastly, we have to understand these helium leaks and get that fixed for Starliner 1. I would say that's probably the largest threat to where we end up flying that Starliner 1 vehicle.
Thank you both. I'm going next to Jeff Brumfeld from National Public Radio. Go ahead, Jeff.
Hi there. Thanks for doing this and taking all this extra time. So I sort of had two quick questions. One was in the presser earlier today, Butch sort of indicated that he manually piloted the Starliner to dock. I was wondering if it was necessary that he had to do that, or if it was planned, or as a result of the thruster failure, if he had to switch to manual. And then my second question is, these dog houses, can you just say, just a little more about them, and if you have to redesign them, how involved would that be, and how much might that delay future missions?
Let me start with the last part of that question first. We would not be redesigning the dog houses. How the thrusters attach to the dog house on a flange area is where this seal is, and that is what we would be talking about doing some potential changes on just taking that. Before that flange is installed on the dog house, we would put a new seal in there instead of the one that is currently planned to install. So for future vehicles, that's just part of the installation. For the current vehicle that is in build right now for Starliner 1, we would have to take the existing flanges or thrusters off, put new seals in, and then put the thruster back on again, which would be an impact, but I don't have an assessment of what that looks like just yet.
And I can answer the part about the manual flying. Butch did take over and do some manual flying during the rendezvous and approach. The actual final part of the approach for the actual docking event was done in auto. The flight computers did that. Butch did a great job. When we needed some manual flying, when we were hot firing the thrusters, as the thrusters failed off, then we would hot fire them to make sure the thruster was good, and we could re-enable that. And he did a great job of some manual flying out on the approach axis out beyond the 250 meters or so. And he commented the vehicle flies great, flies just like the simulator. And from what I've known in the simulator, I'm sure that the vehicle flies great. So.
Thank you. Next, we're going over to Anthony Leone from Spectrum News. Go ahead, Anthony.
Hello. Good afternoon, and thank you all for taking the questions. My question is, will we be getting any updates, immediate updates of the thruster test, and will they be appearing on the NASA blog, the Boeing blog, with these updated thruster tests? I'm sure we're all interested in it. And just the second part, I know that the ISS can hold up to 8 visiting vehicles. So is there a possibility that if that is the case, and there's currently about 6 vehicles, or I believe right now, could the Starliner be pushed to a different dock? And if that's the case, how long it would be expected to be there? Could it be 6, 7 months from now? Thank you.
Yeah, I'll take the last question first, and then we'll comment on the reporting on the thruster testing. Right now, we have two docking ports that can accommodate Starliner and Dragon. The forward port, Node 2 forward, and then Node 2 Zenith, Those are unique docking systems set up for those vehicles, and so those are the only two places that we could put Starliner and Dragons. The other on the Russian system, they have a little different system that they dock the Progress and Soyuz to, so those aren't available. There's not a compatibility with those two, and then obviously the Northrop Grumman Cygnus spacecraft has what's called a berthing interface, a common berthing mechanism. So it's grabbed with a space station robotic arm and then brought in close in some bolts drive to then mate those two surfaces together. So we really have to free up a port to do the rotation coming up, and so one of the two ports have to be freed up for that. And then we'll figure out the right way to communicate the testing results. We're discussing some blogs maybe later in the week, and then I suspect we'll get back together again maybe in the next week or so and do another one of these telecons to give you an updated status.
Thank you. Quick note, we have time for one more question. For those who have questions or follow-ups who have not had a chance to ask them, please reach out to us. We will get a response to you. But we do have some other items coming up, so we have time for one more question. That is Lucy Oberg from AFP. Go ahead, Lucy.
Hi, thank you very much. I just have two quick questions. My first question is for either one of you. If you're checking if the thrusters have sustained any damage from firing them more frequently than anticipated, are the results of these tests going to be applicable for the 5 thrusters that were deselected while docking, or potentially more of them? In other words, were all these thrusters fired more frequently, all of them, and so are you checking if all of them could have sustained damage or only 5? I'm also wondering why this more frequent firing was not seen or analyzed during the uncrewed test. If the thrusters weren't fired this way during the first test, why? And my second question is for Steve. I'm just wondering, were there talks of any kind with SpaceX to see if there would be a possibility to send a Dragon spacecraft in case needed for Butch and Sunny? Thank you.
Yeah, let me see if I got there was a lot of questions there. I'll see if I can touch on all of them. The first question was the white sands testing. Does that data help with all 5 thrusters that were deselected during the rendezvous and docking approach? I would say yes. We tried to design that test based on what we thought was the worst thermally induced set of failures on that one thruster that we picked. So it helps us understand all 5 of them as we do the testing at White Sands. The second question, I think, was why do we have more frequent thruster firings on this flight? Really, there was 2 reasons. One was we had more maneuvers. The crew did some manual maneuvers on the first day of the mission and a few more, so that caused a few more thruster firings. And then there was a change made to protect part of the thruster. There's a part called a solenoid on the thruster that was some concern about being overheated, and so the software was designed to fire the thrusters more frequently, but in shorter pulses. I don't think we totally understood, perhaps pre-flight, what that meant in terms of heat pulses that went into the system and caused the thrusters to have the low thrust that Mark talked about. And then the final question was discussions with SpaceX about sending another Dragon. There's really been no discussion with sending another Dragon to rescue the Starliner crew.
Thank you, folks. That's going to wrap up our time today for this mission status briefing about NASA's Boeing Starliner crewed flight test to the International Space Station. As I mentioned, please reach out if your question wasn't asked or if you have any follow-ups, and we'll get a response to you. In the meantime, you can also follow along on NASA's Commercial Crew blog for mission updates, as well as at Commercial Crew on X and on the NASA social channels.